Concept. Hello, lecturer. My name is Lim Yau Wei Bsc 2504118 Lim Yau Wei, and today I will be presenting two important calculus concepts. First, we will explore how derivatives are applied in economics, particularly in understanding marginal revenue and average revenue. I will also provide two real-life examples to illustrate this concept clearly. First, I will talking about application of derivative in economics. Okay, marginal revenue is done by MR and average revenue is done by AR. The short form lah. So marginal revenue is the additional revenue earned by selling one more unit of a product. It is the derivative of the total revenue function with respect to quantity. So MR is done by marginal revenue, TR total revenue, Q is quantity. So we can get a marginal revenue law. Second is the average revenue. Is the total revenue divided by the number of units sold. So AR stand by average revenue, TR stand by total revenue, Q is stand by quantity. So we can get average revenue. Okay, both difference the both key differences are three. First is average revenue show the revenue per unit on average. Second, marginal revenue show the rate of change of revenue, how much you earn by selling one extra unit. Okay, in perfect competition is AR is average revenue equal to marginal revenue. The second is in monopoly or in perfect markets is average revenue is more than marginal revenue. Okay, first example, I will talking about the fruit cup seller at Jamia University, Malaysia cafeteria. Suppose a food vendor sells each cup of fruit at 8 ringgit. If he sell 10 cups, his total revenue is 80 ringgit, right? So if we want to calculate average revenue, so we need to take the 80 ringgit, the revenue divided by 10. So we can get 8 ringgit for each. Okay, so to sell the cup 11, he give a discount and sell it at 7 ringgit. So the marginal revenue will be 7 ringgit, which is less than average revenue. So its average revenue is more than marginal revenue. This shows as the sellers lowers the price to sell more. The average revenue per item decrease, a common scenario in real world pricing. Okay, the second example is talking about Nike Shoes Company. Okay, suppose the total revenue function is his total revenue is equal to 200. 200 is what? 200 is present the original price, the retailer price. So Q is stand by quantity. So negative quantity power 2. So the marginal revenue is same like before I talked about the marginal revenue is derivative of the total revenue. So we can get 200 minus 2Q. So if let's say we put the variable, we put when the Q is equal to 50. So the marginal revenue, we will get 200 minus 2 times 50. So we can get the answer is 100. So we calculate the average revenue is the total revenue divided by Q, and then we get so we can get 200 minus Q. So the average revenue is 150. The marginal revenue is lower than the average revenue. As the quantity increase, this affect pricing strategy and decision making. And here I will make a mini conclusions. a mini summary. In summary, marginal revenue tells us how much more we earn of each additional unit sold. While average revenue reflects the revenue per unit overall. Understanding the distinction helps business plan pricing and maximize profit. Okay, second, I will talking about the intermediate value theorem. Then the short form is IVT lah. Why is the intermediate value theorem? Okay, the key condition must be three. One is if a function is continuous on the closed interval a and b. F function have a opposite sign. At least one number is c in open interval a b such that fc can get the equation is zero. Okay, let me see the example one. Talking about function. The function equation is x power 2 minus 4. So if we put the variable one in the function, we will get the answer is negative 3. So this is the negative sign. So if we put the variable 3 inside the function, we will get the 5. So the signs are opposite. One negative, one is positive. So the function is continuous on 1 and 3. Yeah. So that as you see in 1 and 3 where the equation will get 0. So indeed if we put the variable 2 inside the function, the root found. So these three we achieve the condition. So we can found by IVT lah if intermediate with intermediate value theorem. Real world application of the intermediate value theorem. Okay, in mathematics, example, we do an example to show that the x3, x power 3 with the function lah, x power 3 minus x minus 1 equation is 0 has a solution between 1 and 2. So we put the variable 1 inside the function, we will get the negative 1. Second, we put the variable 2 inside the function, we will get a 5. So the both we get the equation is opposite sign. So the root must exist between 1 and 2. Okay, in economics, example, suppose as a price 10 ringgit, though the demand is more than supply. So that means it's excess demand. When at the 30 ringgit, supply is more than demand, so that means excess the supply. But the IVT, there must be a price between 10 and 30 ringgit where supply equal demands. So this IVT, intermediate value theorem, is simple, reliable, and guaranteed to coverage. All right. So in conclusion, the intermediate value theorem helps us ensure that a solution exists within the given interval, even if we cannot solve it directly. It is a powerful concept that supports both theoretical understanding and practical computation. Okay, so today we learn application of derivative in economics, have marginal revenue and average revenue. So marginal revenue gain. So the marginal revenue is the derivative of the total revenue function with respect to quantity. And the average revenue is the total revenue divided by the number of units sold. So remember, AR, if A is average revenue equal to marginal revenue is perfect competition. If average revenue is more than marginal revenue, is monopoly and imperfect markets. So if you so the marginal revenue is a lower is you can the marginal revenue can affect the pricing strategy and decision making. Yeah. Okay. Okay. IVT, the three key condition. One is the function is continuous in the on the closed interval a and b, and f function have a opposite sign and exists at least one number c in the open interval such that f the function is equation is zero. So we can found the root. This is okay. This thank you lecturer today. This is today presentation.